Alright, Assalamualaikum class. So today we are going to have a blended learning class. I wanted to proceed with this chapter 1.5 and 1.6. So we're still in this thermodynamics class. We are going to have a look at closed system, rigid tank, and moving boundary work. So today I'm going to finish up the moving boundary work topic. Before we go further, I wanted you to have your course outline with you and also your notes. Yes, this one. Last time we stopped at here. Determination of internal energy. Okay. Alright, so let's recall back last class. You have this energy balance for closed system, where you have summation of energy in must be equal to summation energy out, and then you take the energy out to here, so you are going to calculate for the change inside your system. Now, energy can be transferred in the form of heat, work, and mass, but because we are dealing with a closed system, so mass will remain constant. That's why we Q minus W, right? While change in the system, you have change of the internal energy, change of this kinetic energy, and change of this potential energy. Alright, I will explain to you about this. WB here is work boundary. Work W other here is work by electrical equipment or mechanical equipment. Okay, so Q minus W and minus work boundary, because in closed system we have rigid tank or moving boundary work. So the problem solving maybe will only have rigid tank, so you are not going to have this WB, but sometimes it could be moving boundary work problem, so you are going to consider this WB. So U2 minus U1 here is actually the internal energy, final minus your initial. Okay, so this internal energy will be depends on what type of working fluid you are using. Sama ada vapor ataupun real substances ataupun idle gas, right? Okay, if your U here, right, if the system is using water atau refrigerants, so you are going to use property tables in order to get the nilai of U, which is the internal energy. Or if the working fluid inside your system adalah idle gas, right? So you are going to use this specific heat relation, sama ada CV atau CP, bergantung kepada proses-proses yang berlaku, right? Dan proses-proses tersebut you have already learned in your physics, which is we have isothermal, isobaric, isochoric, adiabatic, and there's another one which is polytropic. Alright, we will skip this page 24 until 27 because this one saya akan sentuh balik bila kita masuk this chapter, properties determination, which is ideal gas equation and your thermodynamic process. Okay, but I'm going to touch a bit about your thermodynamic process yang ada dalam you punya nota yang ini. Okay, which is in next slide. So thermodynamic process ini you have encounter masa you di physics tadi, slide yang saya tunjuk sebelum ni. Okay, so you have one is constant volume, and then you have constant pressure, and then you have constant temperature. Next you have polytropic, tambahan physics dulu tak ada, and then finally you have this one, adiabatic process. Okay, next kita nak tengok, okay, apa kaitan moving boundary work ini, right, dengan these 5 processes yang that I'm going to teach you afterwards, right? So you see, number 1, the word is moving boundary work, and then you ada some typical process, you ada 5. Alright, so now let's have a look at this video. Okay. Right, in this video, it shows you what is moving boundary work actually. Alright, so you have a system, okay, which is, this is the system, right? So you can see that it is expand and then they retract, okay. Alright, so let's say you have a system, so this is your boundary, okay. Yang kat luar ni semua surroundings. Inside here is your working fluid. Okay, working fluid you could be vapor ataupun could be ideal gas, right? Kita tak define lagi. So this boundary will be considered as fixed boundary, but this one is moving actually, right? So let's have a look at the video. Alright, so you see, bila ada energy yang, let's say, bila you ada heating process, okay, imagine dalam sistem ni ada udara, lepas tu you apply heat process dekat sini. So what happen? Molekul udara you akan mengembang menyebabkan piston you tertolak ke atas. So it's going to have this distance, ds, right? Remember in previous class, saya ada explain to you relations of P and V, and I will explain it again in this video. It will explain again. So you have a moving boundary work, okay, which apply dekat dalam equation yang ni. You see here, right? You have moving boundary work, okay, and this moving boundary work will depends on the 5 processes. Ni 5 processes, okay. So let's have a look at here, how the definition, okay. So you know work, kerja adalah daya darat jarak, but in this case adalah sistem yang tertutup. So how they change into volume, okay. Pressure sama dengan force bahagi dengan area. So you bring area ke atas, that's why you got this PA, okay. And then you kalikan dengan ds, which is jarak. So this is meter squared, area, this is jarak, meter. So you akan dapat meter cube onto both. So meter cube is equivalent dengan volume. So that's why you ada dV di sini. Okay. So that's why moving boundary work is equivalent to P dV. Okay, this is the general equations. Okay. Alright, in this case, okay, saya akan terangkan kamu proses yang pertama dalam video itu adalah constant pressure. Okay. So, you ada keadaan 1 dan keadaan 2. Apa yang berlaku? Piston ni tadi daripada keadaan sini and then they extend kepada 2. Right? So, this is integral form. You already learned it in mathematics. So, because of this constant pressure, P you bawa keluar. Okay. P you bawa keluar and finally it becomes P sama dengan V2 minus V1. Alright, sebelum kita pergi ke rumus tu, you need to understand that you need to have you have to plot this PV diagram untuk memudahkan you faham macam mana daripada physical things ni, dekat piston you ni, macam mana you translatekan into this PV diagram. P mewakili pressure, V mewakili volume. Okay, so you will see here, pada P1, volume dia adalah di sini. Okay. Jadi, apabila you apply energy dalam sistem tu tadi, okay, you tengok tadi gambar sebelum ni, you will see yang piston tu daripada 1 ke 2. So, you will see akan ada penambahan volume. Right? So, that's why bila dia plot dekat sini, okay, pada constant pressure tapi nilai volume you bertambah. Okay. You belajar paksi, which is sini adalah nilai kosong, titik kosong kosong hingga infinity. Sini pula titik kosong kosong hingga infinity. Okay. So this is how you translate process of moving boundary work at constant pressure. You translate into PV diagram. Alright, so now, what about the other 4 processes? Okay, so let's see here. You have from point 1 here to this point 2 over here. So let's have a look at your notes, right? Okay, in your notes, okay, that curve mewakili proses pada constant temperature ataupun pada polytropic process. Okay, so if you see yang dekat dalam video ni, right, the process starts at here and then expand to here. So you see volume dekat satu ni lebih kecil daripada volume dekat 2. So means that this process is expansion, polytropic expansion ataupun isothermal expansion. Kenapa? Sebab volume you daripada kecil ke besar. Right? What happen if piston you compress? So it's going to be isothermal retraction. Okay? Ataupun isothermal compression. And this one is going to be polytropic compression. Okay, compress bermakna volume you dekat sini, you compress ke sini. Volume you mengecil. Okay, expand bermakna volume you kecil pergi ke volume yang besar. Alright. So this is how you get the mathematical value, in which is already simplified dekat dalam you punya notes. Alright. So this is for constant temperature punya process. Next page is for polytropic. And next page is your adiabatic. Alright, what does it mean by adiabatic? Adiabatic is the process where the working substance do not receive ataupun do not gives out any heat. Classic example that I can give you is this thermos air tu. Right? Let's say you panaskan air pukul 8 pagi. And then you dah masak air menggelegak, you masukkan dalam termos you, okay, pukul 8 pagi. And then let's say pukul 10 pagi you nak buat air teh, you keluarkan balik air panas tu, tuang dekat dalam cawan. Air ni masih lagi panas. Right? It shows that your termos tu adalah adiabatic process. Heat tak keluar dan heat pun tak masuk. Dia kekal macam tu sahaja. Okay? Alright. For further understanding, saya akan bagi latihan. What I want you to do in that latihan is sama macam video ni. Okay. At first, alright, you explain daripada soalan tu, you explain proses yang berlaku. Okay. Dalam kes ni, you tengok ni, dia adalah expansion daripada volume kecil. And then dia tolak force tu ke atas, so volume you bertambah. So this is expansion. Okay. Ini adalah piston ni punya lukisan. Itu satu yang you perlu buat. Next, dalam latihan tu, saya nak you lukis keadaan 1, keadaan 2. Next, dalam latihan yang saya akan beri tu, saya nak you come up with this plot, this PV plot. Okay, PV plot. You letak dekat mana keadaan P1 you, kat mana keadaan volume 1 you. Dan kat mana keadaan final you. Right? Depends on the soalan. In this case adalah constant pressure. Okay. Nanti saya bagi latihan nanti. I want you to come up with that 2 things. One is your piston cylinder sketch. The other one is this PV diagram sketch. And reference you adalah this video and also your notes here. Okay. If the question asks you about constant pressure, so this is how you punya plot should be. Sama ada dia expand, maknanya kalau expand, volume bertambah ke arah kanan. Kalau retract volume you ke kiri,